A very warm welcome, students, in the another session of mathematics. Today I am going to discuss the remaining questions of exercise 17b. Before that, I'll discuss the problem questions that you have faced in exercise 17b from question number 1 to 8. So a child has sent me query regarding question number 8. So I'm going to discuss question number 8 with you. In question number 8, it is given that ABCD is a square whose two's length, that is AB, is given as 3x minus 8, BC is given is equal to x plus 6. We are looking for the value of x and the length of each side of a square. So first you will draw the figure and will assign the given values here and will get the result. So I have drawn a square ABCD. AB is given as 3x minus 8, BC is given as x plus 6. We know very well that the sides of a square are equal. So we are going to write AB is equal to BC. We'll write AB is equal to BC, side of a square. Now we substitute the value. AB is equal to 3x minus 8 and BC is equal to x plus 6. So I transpose x to the left side and 8 to the right side. So this will give you 3x minus x is equal to 8 plus 6. 3x minus x will give you 2x is equal to 8 and 6 is 14. Therefore, x is equal to 14 by 2, that is 7. Now we got the value of x. Now we are looking for the length of each side. So therefore, each side is equal to, the value of the side is, either you can take 3x minus 8 or you can take x plus 6. Both are equal. So I take x plus 6. X is equal to 7 plus 6, that becomes 13 centimeter. So the length of each side is 13 centimeter. Now we start with question number 9. If the diagonals of a parallelogram are equal in length, show that the parallelogram is a rectangle. Let's see its proof. Children, we are given with that PQRS is a parallelogram. So first that I draw a parallelogram. I named it PQRS. It's given that PQRS is a parallelogram, and what we have to prove? We have to prove that PQR is a rectangle. The difference between a rectangle and a parallelogram is there that each angle of a rectangle measures 90 degrees and it possesses all the properties of a parallelogram. So actually we have to prove that each angle, that is angle PQRS, is 90. What else is given? The diagonals are equal, so that means PR and QS are the two diagonals which are equal in length. Now we talk about the proof of it. For that, what we do, I consider the two triangles, that is P, Q and R, and I consider one more triangle, that is S, Q and R. I consider these two triangles. PQ is equal to SR. Reason, opposite sides of a parallelogram are equal. QR is with both the triangles, that is the common side. PR is equal to QS. It's given that the diagonals are equal in length. Therefore, the two triangles become congruent under the condition of triple S. The moment the two triangles are congruent, the remaining three elements will become equal. Therefore, angle Q will become equal to R. Let's see how to write the proof. So, which triangles I am going to consider? in triangle PQR and triangle QRS, PQ is equal to SR, opposite sides of parallelogram. It's necessary to write the reason every time in geometry. QR is common side and this is the first given condition, second, and the third is PR is equal to QS. The two diagonals are equal. So this is given. Therefore, triangle PQR is congruent with triangle SRQ. What's the condition? Under which criteria they are congruent? That is triple S. The moment the two triangles are congruent, the remaining parts will become equal. Therefore, angle PQR is equal to angle SRQ. Reason? CPCT. We learned that if three elements of a triangle are equal, then the remaining three elements also become equal. So what we say to it? Corresponding parts of congruent triangles. But we know the sum of adjacent angles of a rectangle is supplementary. This is the property of a parallelogram. Therefore, angle PQR plus angle SQR is equal to 180. Reason? Adjacent angles of parallelogram. We can write this way. Therefore, angle PQR is equal to angle SRQ. Each will become half of 180, that is 90 degree. So we have proved that each angle measures 90 degree. Therefore, it is a rectangle. So we'll write therefore PQRS is a rectangle as each angle is 90 degree. So this way we are going to write the proof. Now we discuss question number 10. In the adjoining figure, ABCD is a square and CD is an equilateral triangle. So this ABCD is a square and the CED is an equilateral triangle. Student, remember the properties of a square, that each angle measures 90 degree, opposite all the sides are equal, diagonals are equal. And we should remember the properties of equilateral triangle also, that all the three sides are equal and each angle measures 90 degree. So we are looking for the angle AED, EAB and reflex of angle AEC. Let's see how to solve. I have drawn the figure here. This is an equilateral triangle. That means all these three sides are equal and each angle measures 60 degrees. So this is 60. This is also 60. As we know, it is a square. So this angle D, complete angle, is 90. So what will be the measurement of this angle? It will become 90 minus 60. That becomes 30 degree. This is a square angle, so it is complete 90. This is a part of a equilateral triangle, so it is 60. So this remaining angle will be 30 degree. Now we come to triangle AD and E. As this side and this side of a triangle are equal, because this side is a side of a square as well as of equilateral triangle, and this is also side of a square. So we know that the sides of a square are equal. Therefore, triangle ADE is an equilateral isosceles triangle. So these two sides are equal. Therefore, this angle and this angle will become equal. So let it be x, therefore it will also become x. Now we have to calculate the value of x. So how we are going to write the solution? So first we will write angle EDC is equal to 60 degree. Angle of equilateral triangle. Angle ADC is equal to 90 degree. Angle of square. Therefore, angle ADE is equal to 90 minus 60. That becomes 30 degree. Now which triangle I am going to consider? In triangle ADE. AD is equal to DE. Reason, sides of a equilateral triangle as well as square. Therefore, angle DAE is equal to angle DEA. Angles of isosceles triangle. Therefore, let each measure x degree. Therefore, x plus 30 is equal to 180. What's the reason? Sum of angles of a triangle is 180. Therefore, this becomes 2x minus 30. X becomes equal to 150 by 2, that is 75 degree. Therefore, angle AED is equal to 75 degree. The next angle that we are looking for is angle EAB. That means this angle we are looking for now. See student, again this angle A is complete is 90 degree because it's a square. X we calculated is 75. Therefore, angle EAB will be equal to 90 minus 75, that is 15 degree. So, how we are going to write? Angle DAB is equal to 90 degree. Reason, angle of square. And DAB comprises of two parts, that is angle DAE plus angle EAB is equal to 90 degree. DAE we calculated above is 75. Therefore, angle EAB we are going to calculate. Therefore, angle EAB is equal to 90 minus 75 degree. Therefore, angle EAB is equal to 15 degree. In the third subpart, we are looking for reflex of angle AEC. So first we will find angle AEC. So this is x, this is 70, x value is 75. So total angle AEC is 75 plus 60, that gives you 135. Now we calculate its reflect by subtracting it from 360 degree. So how we write? Let's see. So firstly I calculate angle AEC, that becomes 75 plus 60 degree, that is equal to 135. Now we'll find reflex of angle AEC is equal to 360 minus 135, that is equal to 225 degree. So this way we have completed the solution of question number 10. Now we come to question number 11. In the adjoining figure, ABCD is a parallelogram. So we are given ABCD is a parallelogram. So remember the properties: opposite sides are parallel and equal, opposite angles are equal, and what are the rest properties? And AX is parallel to CY. It's given that AX is parallel to CY. Prove that AX is equal to CY and AXCY is a parallelogram. Let's see its proof. So I have drawn a figure for you here. This is the figure given. It's given that AX is parallel to CY. So these two sides are parallel. So given, what is given to us? ABCD is a parallelogram and AX is parallel to CY. It's given. What we have to prove? AX is equal to CY. And in the second part, we are supposed to prove that AXCY is a parallelogram. Now we are going to write the proof. How I am going to prove that AX is equal to CY? See children, for that I am considering these two triangles. I consider triangle CY and O. I name the point O where the two diagonal intersect. And AOX. I take these two triangles. This angle is equal to this because the lines are parallel. Alternate interior angles will be equal. These two are vertically opposite angles. And OA is equal to OC because we know that the diagonals of a parallelogram bisect. So OA is equal to OC, angle AO is equal to angle O, angle A is equal to angle C. Therefore, under the condition of angle, side, angle, angle, side, angle, the two triangles become congruent. The moment the two triangles are congruent, the remaining parts will become equal. Therefore, AX will be equal to CY. Let's see how to write the proof. So, which two triangles I am going to consider? I consider triangle YOC in triangle YOC and triangle AOX. What is given? The first condition given is angle AOX is equal to angle COY. Reason VAO, that is vertically opposite angles. Second part, OA is equal to OC. Diagonals of parallelogram bisect. Third is we are going to consider that angle OAX is equal to angle OCY. Reason alternate you can write in short ALT, alternate interior angles. Therefore, triangle AOX is congruent to triangle COY. What is the criteria under which they are congruent? It is angle, side, angle property. Therefore, X is equal to CY. What's the reason? CPCT. That means corresponding parts of congruent triangles are equal. So we recall the theorem number 3. Theorem number 3, it was given if we have a one pair of a side opposite side parallel and equal, then that quadrilateral so form is necessarily a parallelogram. So we'll apply theorem number 3. So we'll write as Ax is equal to Cy and Ax is parallel to Cy. Therefore, X Cy is a parallelogram. Theorem number 3. No need to write the theorem number, but theorem is there. You'd recall theorem number 3. And for that is for your remembrance. So we have proved the question. Now the next question is question number 12. Question number 12, ABCD is a parallelogram. It's given if the bisectors of angle A and angle B meet at point P, show that APB is a right angle. You can do it very easily, student. If you find difficulty, then I'll discuss that also with you. Now I proceed with question number 13. In the adjoining figure, ABCD is a parallelogram. EF is the line segment such that EF is parallel to AC. Angle AT is given 32 degree. Angle CTF is given 26 degree. We are looking for angle ABC. Let's see its solution. I have drawn the figure for you here. Students, see, this is a complete straight angle. This is 32. This is 26. And this part we calculate. The sum of these three is 180 because they are forming a straight line. So if you calculate, this angle is going to become 30 and 20 will give you 50, 58. 180 minus 58 will give you 122. If this is 122, so this is also going to become 122. Why? Because it's a parallelogram, opposite angles are equal. See how we write the solution. So what I am going to write here, angle EDA plus angle EDA plus angle ADC plus angle CDF is equal to 180. What's the reason? Straight angle. Now I substitute the value of angle. This is 32 degree. This we are looking for, and the angle CTF is equal to 26 degree. That is equal to 180. Therefore, angle ADC is equal to 180 minus, if we add both, that is going to give you 58 degree. Therefore, angle ADC is equal to 122 degree. Therefore, angle ABC is equal to angle ADC. Important to mention the reason, opposite angles of parallelogram. Therefore, angle ABC is equal to 122 degree. Now we come to question number 14. In the adjoining figure, AB is equal to AC. AB is equal to AC. CP is parallel to BA, and AP is the bisector of angle CAD. Okay, so what we have to prove? BAC is equal to BCA and ABCP is a parallelogram. Let's see its proof. So I have drawn the figure. Student, these AB and AC are equal. It's given. That means their opposite angles are going to become equal. Therefore, these two angles are equal. And angle DAC. So this is the exterior angle of this triangle ABC. If I draw a line on triangle ABC, this forms its exterior angle. And this AP is the bisector of angle DAC. That means these two parts are equal. So, as this is equal, let this is x. So this will also become x. Therefore, this complete angle is going to become 2x. Now this is the bisector. So this half will become x. This also will become x. Now so we concluded angle PAC is equal to angle BCA. Got it, children? Let's see how we write the proof. So what it is given? Angle DAP is equal to PAC. That means AP is the bisector. And we have to prove that these two angles are equal and ABCP is a parallelogram. So let's write its proof. How we write it? In triangle ABC, angle B is equal to angle C. Reason? AB is equal to AC. As two sides are equal, AB is equal to AC, therefore angle B is equal to angle C. And angle DAC is equal to angle B plus angle C. Reason? Exterior angle is equal to sum of opposite interior angles. But angle now I write the complete name of this angle. Angle B is actually angle ABC and this angle C is angle ACB. As these two are equal, so can we write in place of this twice angle ACB? Now I multiply with half on both the sides. So I write the solution on the next page. Now I multiply half on both the sides. This is D. Half of angle DAC is equal to angle PAC. And these two gets cancelled. So what we are left with? ACB. This is proved. First part we were supposed to prove that PAC is equal to BCA. Second part we have to prove that ABPC is a parallelogram. As PAC is equal to ACB, therefore AP is equal to AP not equal. AP is parallel to BC. As alternate angles are becoming equal, these two angles became equal just now. So therefore line AP is parallel to line BC. So we write AP is parallel to BC. And what is given? AB is parallel to PC. It's given. Therefore ABCP is a parallelogram. So this way we are going to write the solution. See student, I have completed up to question number 14. Do complete up to question number 14. Do question number 12 of your own. If you have difficulty in that question also, I'll discuss in the next session. The remaining questions we'll do in the next section. That's the end of the session. Have a good day.